While much is known about the composition of our planet, scientists are still unsure how Earth initially formed. But two new studies have shed light on this mysterious process and suggest that Earth's distinctive chemical composition may have been shaped by a cowboy-building job as molten rock evaporated from the precursors of planets. These findings could help to explain how Earth, Mars and other rocky bodies in our solar system formed. Previous studies have suggested that the building blocks of Earth were chondritic meteorites. But our planet has a different composition to these space rocks. And while some explanations for this variation have been put forward, not all differences have been accounted for. But two new independent studies could help to fill this knowledge gap. In the first study, researchers from the University of Bristol found that the evaporation of molten rock from growing planets, known as planetesimals, explained the difference in magnesium isotope levels in Earth and chondritic meteorites. Dr. Remco Hin, who led the study, said, "We have provided evidence that such a sequence of events occurred in the formation of the Earth and Mars using high-precision measurements of their magnesium isotope compositions. Magnesium isotope ratios change as a result of silicate vapor loss, which preferentially contains the lighter isotopes. In this way, we estimated that more than 40% of the Earth's mass was lost during its construction." This cowboy-building job, as one of my co-authors described it, was also responsible for creating the Earth's unique composition. The second study by researchers at the University of Oxford backs up these findings. Researchers recreated processes that occurred during Earth's formation by melting rock in a furnace. They found that some elements could escape in vapor released from the molten rock in proportions similar to that observed within Earth. In their study, also published in Nature, the researchers, led by Dr. Ashley Norris, wrote, "We argue that melting and vaporization on precursor bodies and possibly during the giant moon-forming impact were responsible for establishing the observed abundances of moderately volatile elements in Earth." Both groups suggest that collisions with planetesimals, such as the moon-forming impact, may have driven the melting and evaporation of the growing bodies. Dr. Hin added, "Our work changes our views on how planets attain their physical and chemical characteristics. While it was previously known that building planets is a violent process and that the compositions of planets such as Earth are distinct, it was not clear that these features were linked. We now show that vapor loss during the high-energy collisions of planetary accretion has a profound effect on a planet's composition. This process seems common to planet building in general, not just for Earth and Mars, but for all planets in our solar system and probably beyond. But differences in the collision histories of planets will create a diversity in their compositions.